So what we just learned how to write is called a molecular equation. It shows the complete neutral formulas for all of the compounds as if they were molecules. And so we see here in this example, potassium hydroxide is aqueous, but we're writing it as if it was a molecule. Magnesium nitrate, potassium nitrate, and magnesium hydroxide. If we look at what's actually going on in the solution, though, these aqueous substances, the ions are not together. They're separate, right? The water molecules come around and enable the ions to separate from each other. So here the potassium and hydroxide ions are separate. The magnesium and the nitrate ions are separate. Here the potassium and the nitrate ions are separate. Here with the solid, this is and should be written as magnesium hydroxide, MgOH2, because these guys are together. They're the precipitate that falls to the bottom of the beaker. So this is the molecular equation. We also have what's known as a complete ionic equation showing all of the ions that are present. And this shows them as they are actually present in the solution. And then we have the net ionic equation that shows only the things that are actually changing. So the complete ionic equation is like your gross pay, and this net ionic equation is like what you get after they take out all that other stuff, right? Taxes and everything.
Can you show us examples?
Yes, examples are coming. So to write complete ionic equations, we're going to write any aqueous strong electrolytes as ions. So what are the strong electrolytes? Well, any soluble salts, soluble ionic compounds. Chemists use the word salt to refer to ionic compounds. Strong acids and strong bases. Anything that's insoluble, a weak electrolyte or a non-electrolyte are written as molecules because they do not separate completely or at all sometimes. So if you have something that's has the state solid, liquid, or gas, you leave it alone. And if you have a weak acid, those are also written in molecular form. So the book doesn't tell you which are the strong acids yet, so I'll just jump the gun and tell you. Oops. Those are the strong acids. So if you have one of those acids, that falls in this top category, and you separate it and write it as ions. Because strong acids ionize completely. And so that's how they actually are in a solution. They separate into their ions. Weak acids ionize somewhat, but there's also a lot of the intact molecules. So weak acids are always written as molecules. So here's this reaction from earlier, the lead nitrate and the potassium chloride being mixed. And are forming solid lead 2 chloride and aqueous potassium nitrate. So to write the complete ionic equation, I'm going to start out by looking at the state symbols. If it says AQ, there's a pretty good possibility I need to separate it into ions. The only aqueous things that do not separate are weak acids. In this equation, I don't have any acids, so I don't have to worry about that. So here, this one's aqueous. I'm going to write it as its individual ions. So lead 2 nitrate is present in the solution as lead ions and nitrate ions. From the formula, I know that there will be 2 nitrate ions for every 1 lead ion. And so I'm going to write those as separate pieces. This next one is also aqueous, and so I'm going to write this as K plus and Cl minus. This equation was balanced, and I can preserve that if I pay attention to what I'm doing. If I have 2 KCl's, that means I have 2 Ks and 2 Cl's. Over here, this one has the state symbol solid. I leave it alone. Just copy it down. And then at the end, I've got aqueous again, so I'm going to separate that into the ions. Any questions? Separate aqueous things except weak acids. Don't separate anything else. So if we're looking at this complete ionic equation, one of the reactants is 2 moles of nitrate ions. And one of the products is 2 moles of nitrate ions. Did anything happen to the nitrate ions? No. They came to the party, they were watching, and they end up just watching. Nothing happened to them. We call those spectator ions because they're just hanging out watching what's going on. They're watching lead-2 chloride making out on the back porch. That's what's happening. Who else is just watching? Potassium? Potassium came in, and potassium goes home by himself too. So those are spectator ions. They do not participate in the reaction. Just like you go to a boxing match, right? And the spectators do not leave with black eyes and bloody noses. They were just watching. It's the guys in the ring that something happened to. So when we take the spectators out, that gives us the net ionic equation. There we're looking at just the things that are actually changing. So the spectators, we essentially cancel them out. The 2 nitrates didn't do anything. The 2 potassium ions didn't do anything. And then we're going to write down what's left. So we've got lead-2 reacting with 2 chloride ions to form lead-2 chloride solid. This is the net ionic equation. That's the bottom line. So complete ionic equation is complete. It has all the ions. Yeah.
So you said that weak acids are not split up? Or,
Weak acids are not split up.
and how do we know it's a weak acid if it's not a strong acid?
Yeah.
Okay.
It's a weak acid if it's not a strong acid. And I lost that list, but yeah. It's a weak acid if it's not a strong acid. There are 6 strong acids. Anything else is weak. And you know it's an acid because it starts with what letter? H. So here we're going to do this reaction, and we're going to write a complete ionic and a net ionic equation. So going through here, and I'm looking at this, the state, AQ, AQ, liquid, AQ. If it's AQ, there's a good chance I'll have to separate it into ions. I always separate everything except weak acids. Here I do have an acid. So here's HI. And we haven't officially covered this yet, but I told you HI is a strong acid. Strong acid is a strong electrolyte, meaning it separates into ions. A weak acid is a weak electrolyte. It only forms a few ions. So I'm going to separate this one and this one. I'm not going to separate the liquid. And I'm going to separate this one. Now here's a question. Is water an acid? Yes and no. It is not an acid as we have described it, and it's not named as an acid, and you're not going to split it into ions. It does start with H though, so that could mess with you. So 2HI. I'm going to split that into ions. If I have 2 formula units, I have 2 H's and 2 I's. So I have 2 hydrogen ions, and they are aqueous. And I have 2 iodide ions, and those are aqueous. Okay? And then I have this aqueous compound, barium hydroxide. So there are 2 ions in that compound, right? Barium ions. Barium is 2+ because it's in group 2A. And then what's the other ion? Is it OH2? No, it's OH minus, and there's 2 of them. So the 2 outside here tells me there's 2 of what's inside the parentheses. So this is 2 hydroxide ions. And that's aqueous. We should not be seeing ions that were not on that list of ions to memorize. Right? You should not be making up new polyatomic ions here. These are our same old friends. Water has the state symbol liquid, so I'm going to leave it alone and just copy it. And then barium iodide is aqueous, and so I'm going to write the individual ions. Ba2 plus, and I2, that's 2 iodide ions. That's my complete ionic equation. Right. Solid or liquid or gas, we leave it alone. Because what we're trying to do here is describe what does the solution actually look like. And this solution, in the beginning, looks like we had hydrogen and iodide ions. Those came in a beaker together, and barium and hydroxide ions came in a beaker together, and those ions were completely separated from each other. When we mixed them, a chemical reaction occurred and water was formed. Water is a molecular compound. And then we had barium ions and iodide ions that are still floating around separately. We could write a formula for barium iodide, but it doesn't really describe what's happening because aqueous barium iodide is actually barium and iodide ions separate from each other. So that's what the ionic equations are trying to describe.
For the barium hydroxide,
Mm-hmm.
wouldn't it be insoluble?
That's a good question. So, wouldn't barium hydroxide be insoluble? Well, hydroxide compounds are generally insoluble, but barium is one of the exceptions. It's slightly soluble. Yeah.
It's just weird.
Right, yeah. Yeah, it'd be great if there weren't any exceptions, but there are. So, any other questions? So that's the complete ionic equation. We could call that the CIE, complete ionic equation. That's one I made up. Nobody uses that. How do we find the net ionic? We're going to cross out the spectators. So we look at who's the same on both sides. Well, barium. Nothing happened to barium. And iodide. Iodide doesn't change. So for the net ionic equation, and this is an abbreviation that is used, NIE, net ionic equation, I'm just going to copy down what's left. 2H plus aqueous plus 2 hydroxides aqueous, making 2 H2O liquid. Is there anything weird about that equation? Are the coefficients in the lowest ratio possible? 2, 2, and 2. Could make that 1, 1, and 1, right? Yeah. So this should be written H plus OH minus, making H2O. That's not something I'll try to trick you with on an exam. But if you come up with this as your net ionic equation, and this is the correct choice, then that one won't be shown, and you need to recognize, oh yeah, these are essentially the same thing. Yeah?
Why would water be separated? Is it because it's a liquid?
Because it's a liquid.
Okay, so our solids and liquids would stay together,
Solids, liquids, and gases stay together.
but aqueous is
Yes.
Okay.
Aqueous is dissolved, and so that would include the soluble ionic compounds. Yeah. In these type of reactions, we're not going to see soluble molecular compounds. like sugar, those would also be written as molecules, though, because there's no ions to separate them into. So if it says S, L, or G, leave it alone. If it says AQ, the chances are good you separate it. The only exception is weak acids. Question in the back?
Could you explain why you cancel out the iodine and barium?
Yeah, why did I cancel these out?
I see that they're on both sides, but
So why am I canceling out? I've got barium here as a reactant and barium as a product. So barium came to the party. Barium did not get involved with anyone. Barium left the party. When the party's over, barium is unchanged, right? He was just watching. He's a spectator. Same thing with iodide. I'm sorry, iodide's over here. Iodide came to the party, and at the end of the day, she's still single, right? Still soluble, not involved with any other ions. So those show up in the complete ionic equation because they were there. But they weren't involved in becoming a solid, or a liquid. So here, hydrogen ion and hydroxide ion came in separately, but they became a unit at this party, right? So they became a water molecule. So they were changed. So in the net ionic equation, we don't look at the spectators, we just look at the action. So just like, when they comment or, they write a news article about a boxing match, do they talk about what the spectators were wearing? No. What they ate, what kind of snacks or concessions there were, how loudly they cheered? No, nobody cares about that. Those people are just watching. We just want to know about what happened in the boxing ring, right? So here we're interested in who got into a relationship. We don't care about who else was just hanging out at the party. Does that make sense? Any other questions? Yeah.
the only reason that we canceled out the twos was because they were all the same, so they were like all different numbers.
Right. You only cancel out the things that are the same. It's a little bit like a math equation where if you have A plus B equals A plus C, you could simplify that, right?
So like 4, 2, and 6 would be 2, 1.
But if you had A plus B forms C plus D plus E, nothing's the same, then they all stay. So it's possible to have a net ionic equation and a complete ionic equation that are the same. It's unusual, though. Any other questions? This is another one of those things that once you can see what's happening, it's not hard. But you have to get to that point where you can see it. And that might involve asking a lot of questions. But that's what I'm here for, is to answer your questions.